Now that we have a basic idea about what the inverse of a function is, I do want to talk a little bit about for which functions do we have inverses. Perhaps that's a surprising question to ask, but it turns out that not every function has an inverse. Let me show you a problem that a function can have which causes it not to have an inverse. Let's suppose that we have a function f, and f of 2 is equal to 4. And let's also suppose that f of minus 2 is equal to 4. Now, we know that the inverse function will switch the inputs and the outputs. So what will be the inverse function evaluated at 4? You might be tempted to say something along the lines of, well, maybe it's 2 and negative 2, but functions can't have multiple outputs. We can't say that this is both negative 2 and 2. The conclusion of this would be that this function f doesn't have an inverse. Now, the problem is that we have multiple inputs here, 2 and negative 2, which have the same output of 4. Anytime your function has multiple inputs that result in the same output, you're not going to have an inverse function. So for example, if we knew that f of 3 was equal to pi and f of 7 was equal to pi, then the function that we're describing is not going to have an inverse, because as soon as we try to do f inverse of pi, we wouldn't be able to say what this is, because there's multiple inputs that give me pi as an output. So if you have multiple inputs that have the same output, well, your function won't have an inverse. And for that reason, we have a special name for functions for which every single input has a different output. In mathematics, that's called a one-to-one function. So f of x is 1-to-1 if every input has a different output. And frequently, instead of writing 1-to-1, I'll simply put 1-1 to represent 1-to-1. Now, functions will only have inverses if they are 1-to-1, and every 1-to-1 function will have an inverse. Because of this, it's useful to be able to recognize when a function is 1-to-1, because if you can identify that a function is 1-to-1, then you also have identified that this function has an inverse. The easiest way to identify if a function is 1-to-1 is by looking at the graph. Let's go ahead and sketch a graph here, and we could talk about how we can identify whether a function is 1-to-1 from this graph. So I think I'll go ahead and include some axes, x and y. Let's indicate what our scaling is. So we'll let that be 1. So there's 2, 3, 4, 1, 2, 3, 4. Let's go ahead and assume that our graph looks something like this. Go ahead and connect with a smooth curve. So we have this parabolic looking graph here. So there's 2, 4, there's 1, 1 on the graph. And now I can tell you that this graph is not the graph of a 1-to-1 function. That is, if I label this function f of x is not 1-to-1. And the reason is because I can identify an output that is a y value with multiple inputs. For example, this point 2, 4 is on the graph of f of x, which means f of 2 is equal to 4. In other words, the y value of 4 is the output for the input of 2. There is another point on the graph which has an output of 4. It's on the left, it's negative 2, 4. So the output of 4 has multiple inputs. That means that this isn't the graph of a one-to-one function. One easy test to determine if you have multiple inputs which give you the same output is to draw a horizontal line at that output. So for example, for the output y equals 4, if you draw a horizontal line at that y value, we get two intersections. And the x values of the intersections will tell us the inputs, 2 and minus 2, which give us that output of 4. Now, the important thing here is that if your horizontal line intersects the graph twice, you're going to have multiple inputs which give you that output. So for example, at y equals 1, you have multiple crossings. You have inputs, multiple inputs, which give you the output of 1, namely plus and minus 1. If you draw a horizontal line at that looks to be about -2, you don't get any crossings, and that means that there are no inputs which give you this output. The result of this observation is called the horizontal line test, and the horizontal line test will help you determine if the graph of a function is a one-to-one function, or perhaps more precisely, whether a graph is the graph of a one-to-one function. The horizontal line test says, let's go ahead and label it horizontal line test. It says that f of x is one-to-one if and only if every horizontal line intersects the graph of f at most once. So it's okay if there are horizontal lines that intersect the graph 0 times, but you can have no horizontal line intersecting the graph more than once. So for example, this graph would be one-to-one, because if you draw any horizontal line, then the maximum amount of intersections you get is 1. So this would be the graph of a one-to-one function. So remember, inverses of functions only exist for one-to-one functions, and the easiest way to find out if a function is one-to-one is to look at its graph and perform the horizontal line test. I also think it's useful to remember why the horizontal line test works. Remember, when you draw a horizontal line, you are determining which inputs have the output for the y value of your horizontal line. So the y value for this horizontal line that I've just drawn is a little bit more than 3. And so we can find the intersection with the graph, and we can find the input which has that output. It looks to be about 2.5. So when you draw a horizontal line and it's intersecting more than once, then what's happening is your horizontal line is saying that, hey, there are multiple inputs which have this output. That's precisely what it means for a function to not be one-to-one.